This session we are going to discuss about assignment problem using brute force technique. So first we'll discuss what is an assignment problem. So assignment problem is that we have to assign the given n jobs to n persons. So they'll be giving us n jobs with n persons. So in this we have to assign these jobs, the given jobs, to the n persons. So for this, the number of possibilities is actually n factorial. For example, consider the number of jobs given to us is 4. So which means 4 factorial. So we have 24 possibilities of assigning this n jobs, that is the 4 jobs to 4 persons. So we have to take all the 24 possibilities and find which is the minimum number of hours to complete that particular job. For example, say the number of jobs given to us is actually 5. So the number of possibilities could be 5 factorial, which is 120. So when it is 120 possibilities, it is quite difficult for us to compute it. So here we are using a different method which is named as Hungarian method. So here we are just going to solve the assignment problem using Hungarian method. Here I have just taken a matrix where here these rows represents the persons and this columns represents the jobs. So consider the first row to be the person 1, person 2, person 3, person 4 and person 5, and the column wise it is job 1, job 2, job 3, job 4 and job 5. So here the value of n is equal to 5. That is, we have 120 possibilities where we can assign this P1 to P5 persons to J1 to J5 job. That is, each and every single job to be assigned to only a single person. We cannot assign 2 jobs to a single person or 2 persons to be allocated with 2 jobs. We have to assign a single job to a single person and a single person to be assigned to a single job only. So here these numerical values represents the total amount of time to complete the job. For example, say this 5 represents 5 hours. When we allocate person 1 with job 1, he takes 5 hours to complete. Similarly, all other numerical values are being represented here. So here we are just going to use Hungarian method where we have majorly 3 steps to follow. The first one is row deduction, where we will be considering the given matrix row wise, and the next one is column deduction, where we will be considering the matrix from the row deduction, and the last one is the optimality test. So we'll go stepwise. So first we'll consider the first step, which is row deduction. In row deduction, we have to consider the matrix which is given to us row wise. So consider the first row. So we have to consider the row and what is the minimum number in that particular row. So in this first row, what is the minimum number? Consider in the first row the minimum number is 4. So I am taking the 4 and subtracting this particular minimum number 4 with all other elements in that particular row. So 5 when subtracted with 4, 1. Next 11 minus 4, it is 7. Next 10 minus 4, 6. 12 minus 4, 8. 4 minus 4, 0. Next we will move to the next row. In the next row, the minimum element is 2. So when we are considering this, so minimum number is 2. So we have to subtract this 2 from all other elements in that particular row. So it is 0, 2, 4, 1 and 3. Consider the next row. In the next row, the minimum number is 3. So 3 minus 3, 0, 12 minus 3, 9, 5 minus 3, 2, 14 minus 3, 11, 6 minus 3, 3. In the next row, we have to consider the minimum number. So the next row, the minimum number is 4. So 6 minus 4, 2, and then 10, 0, 7 and 3. Consider the next row, the minimum number is 5. So it is 2, 4, 3, 7 and 0. That's it. So this is our row deduction. We have to consider each and every row. The minimum element in the row should be subtracted from all other elements in that particular row. So after doing this, the next step is our column deduction. So for column deduction, you have to consider the matrix which we have got in the row deduction. That is, the row deduction matrix is the input for column deduction. So you have to consider the each and every column in this particular matrix. So in this column, which is the minimum element, 0. So 0 when subtracted with all other elements will return the same values. So I am just copying the same elements since I have the minimum element in the particular column to be 0. We'll move to the next column. The next column, the minimum element is 2. So I am subtracting 2 with all other elements in that particular column. So it is 5, 0, 7, 8 and 2. In the next column, we found 0. So we are just replicating all the elements in that particular column to be 6, 4, 2, 0 and 3. In the next column, we found the minimum element to be 1. So we are subtracting that 1 from all of the elements in that particular column. So it is 7, 0, 10, 6 and 6. Next column we found 0 is the minimum element. So no change. So it is 0, 3, 3, 3 and 0. That's it. So this is the second test. So after this, we have to go on with allocating the persons with each and every job. For that, we have to consider row scanning. That is, we have to consider the first row and find is there any zeros in that row. So we have to find for only single zeros in a particular row. So we have found a single zero in that particular row. So I am just marking it with a square, which means person 1 is eligible for doing the job 5. So this particular job 5 is now allocated to person 1, which means person 1 can do job 5. So I am just striking out this particular column. So this job is assigned to a particular person. So no one can do it. Next, we'll move to the next row. Here we find 3 zeros. So we'll neglect that particular row and jump to the next row. In the next row, we find only a single zero. So I am marking it with a square, which means person 3 is able to do job 1. So I am striking out the job 1 entirely. Next, we'll consider the next row, which is fourth row. Here we found a single 0, which means P4, that is the person 4 will be able to do job 3. So I am striking out this particular job. So we have when we jump to the last row, we find no zeros. So we are going to skip it. So this is the row scanning procedure, and after this row scanning, we'll be doing our column scanning. Here the first column is being striked out. So I am moving to the next column. The next column, I have to see whether I have found any one single zeros. In the second column, here we have a 0. So I am marking it with the square. Okay, which means this particular job 2 is being assigned to person 2. Job 2 is assigned to person 2. So when you are going to scan the column and put a square to the 0, you can strike out that particular row. That's it. And afterwards, we move to the next column. It is being striked out. Next, we move to the next row. It is also being striked out. Here we don't find any 0. So we skip it. So totally, we have done the row scanning and allocated few jobs to few persons. And next, we have done column scanning and allocated few jobs to few persons. So here, next we have to do our optimality test, which means whether all the jobs has been assigned to all the persons. So for doing that optimality test, so we have to count for the total number of squared zeros over here. Here the squared zeros are 1, 2, 3 and 4. So 4 squared zeros are there, and here it is very clear that we have 5 jobs. We have to check for the squared zeros and the number of jobs. Squared zeros and number of jobs. When they match each other, it means that all the jobs has been assigned to the persons correctly. If suppose they don't match each other, then we have to move for another step with the help of the matrix where we have obtained earlier in the last step. So we have to consider this particular matrix, and in this particular matrix we have to find which is the minimum number in this particular matrix. So overall, leaving the deleted cells, consider only the undeleted cells. So undeleted cells, in the sense, here we have strike out these second row and first column, third column and fifth column. Leaving the striked out cells, consider only the undeleted cells. In this undeleted cells, you have to find the minimum number. So the minimum number in undeleted cells. Cells is, actually we have 5, 7, 8, 2, 7, 10, 6, 6. So 2 is the minimum number. So you have to take the 2. So you have to, first step is this, after which you have to add this minimum element, which is 2, to the intersection points. So intersection point, in the sense, in this diagram the intersection points is particular here, here and here. That is the line which crosses the vertical and the horizontal line. So we have 3 intersection points over here. So you have to add this particular minimum element 2 at that particular intersection points, and then this minimum element 2 should be subtracted, this to be added and this to be subtracted from the undeleted cells. That is undeleted cells, in the sense this 5, 7, 8, 2, 6, 6, 10, 7. So from this undeleted cells you have to subtract this 2. So here we are in position to construct a new matrix with this particular existing matrix following these 2 rules. That is, the minimum number in the undeleted cells is 2. So you have to add 2 to the intersection point, and then you have to subtract 2 from this undeleted cells. So 3, in the sense 3 intersection points are there. So this is plus 2 and this is minus 2. So I am going to draw the matrix here. So I have drawn the matrix. Now we are just going to do the procedure, what we have to do. So the first step is you have to find the minimum number. I have found it is to be 2. So this minimum number to be added with the intersection points. So as said earlier, there are 3 intersection points, 1, 2 and 3. So we have to add 2 to this points. So here in this intersection points the value is 0. So when we add 2 to this, the answer is 2. And next, in this intersection point the value is 4. So 4 plus 2, it is probably 6. Next, in this point we have 3. So 3 plus 2, it is 5. So the first step where we have to add in the 3 intersection points with plus 2 is over. Next is what? We have to subtract the 2 from the undeleted cells, that is this particular area where 5, 7, 8, 2, 7, 10, 6, 6 are there. We have to subtract it. So just consider the second column where 5 minus 2, the answer is 3. Next 7 minus 2, the answer is 5. 8 minus 2, the answer is 6. 2 minus 2, 0. Next, consider the fourth column since it is undeleted. So 7 minus 2, it is 5. 10 minus 2, it's 8. 6 minus 2, 4. And again 6 minus 2, 4. So we have done the first two steps, which is intersection points. We have to add that plus 2. And in the undeleted cells, you have to subtract minus 2. Okay. And what could happen to the remaining deleted cells? The remaining deleted cells should be copied as such. So it is, I am just copying the undeleted cells as such. So it is 1, 6, 0, 0, 0, 0, 2, 3, 2, 0, and again it's 3, 2, 3, 0. After this, you have to again do that row scanning and column scanning. So probably in this step we'll be getting our answer. So here the first row we have only 1 0, so I am marking it in square and striking out that particular column. And after this second row we have 2 zeros, so I am just keeping it. Moving to the third row, I have found only a single 0. I have marked it with a square and striked out that particular column. Next row, a single 0, so strike out that particular column. Next row, a single 0, mark it with a square, strike it out. So we have completed row scanning. Next, when we consider column scanning, we have just only one column which is unstriked. So consider that column and search for the 0. Here we have a single 0, so I am marking it with square and striking out it. That's it. So now we have to count for the total number of squared zeros. So it's 1, 2, 3, 4 and 5. So we have 5 squared zeros and we have exactly 5 jobs. So it's matched, which means the jobs has been allotted to persons correctly. So we have to finally write our answer. So I am just plotting it. This is P1, P2, P3, P4, P5 with J1, J2, J3, J4 and J5. So the squared zeros represents the person is being allotted with that particular job. So here person 1 is assigned with job 5. Person 1 is having a squared 0 in the 5th column. So here means person 1 with job 5. Next person 2 is allotted with job 4. Next person 3 is allotted with job 1. Person 4 is allotted with job 3. Person 5 is allotted with job 2. That's it. So with the squared zeros, I am just writing it. So P1 with J5, P2 have the squared 0 over here. So J4, P3 J1, P4 with J3 and P5 with J2. So after which we have to just estimate the total number of hours. We have already assigned the persons with the jobs. Now we have to just go ahead with the total number of hours alone. So this hours can be computed with the initial matrix which was given in the question. So person 1 J5. So this is person 1. For J5, person 1 for doing job 5 he takes 4 hours. So this is 4 hours. Person 2 for doing job 4 he takes actually 3 hours. So it is 3. Next, consider person 3 for doing job 1 he takes exactly 3 hours. So 3 hours. Next, person 4 for doing job 3 he takes 4 hours. And person 5 for doing job 2 takes 9 hours. So 9 hours. So we have to sum up all the hours which has been assigned to the persons and the jobs. So it is actually 23 hours. So these 5 jobs can be assigned to 5 persons, and the minimum number of hours the persons can complete these 5 jobs is 23. Thank you.